Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam and we are focusing on ISS 2026. We have completed the topics econometrics of statistics paper 3 and now we are moving in sampling techniques in which we have covered almost half of the syllabus. We have covered simple random sampling with replacement and without replacement, stratified random sampling and systematic random sampling. So now moving on further, we will do ratio estimator. There are three kinds of estimator: ratio, product, and regression. So what is the need of these estimators in our sampling techniques? When we have two variables, one variable is the study variable on which we have to make the study or which we have to calculate, and the other variable is correlated with the study variable and is known. Then we use these three kind of estimators. The first one is ratio estimator. In ratio estimator, y and x, let us suppose y and x are two variables, where y is study variable and x is auxiliary variable. What is auxiliary variable? Variable which is is which is pre-known, or variable which is correlated with x, or correlated with x, right? Now suppose we have two terms, xi and yi. Xi shows the value of x and yi shows the value of y. Xi's may also be the values of yi's because they are pre-known values which are correlated with y's, so it can also be the case. Let us take one example. Suppose yi is the production in ith plot. Suppose yi is this. Then xi is the known value of yi. Xi can be the area of ith plot, or it can also be the production of ith plot of the previous year. So using xi's, we can find yi's. Right? Using xi, we can find yi's. So this was your one of the example of what is a ratio estimator. Now let us take let x1, y1. These are the paired samples that we take. For the value of y1, there is a known value of x1. For the value of y2, there is a known value of y2. x2, sorry. So x2, y2 up till xn, yn be a paired sample of x comma y of size n, drawn with simple random sampling without replacement. SRSWOR. We draw it with the help of SRSWOR from population size of size capital N. Then the ratio estimator can be written as the ratio estimator of y bar is y bar cap This is the ratio estimator, so I'm putting it I'm putting R in the subscript of this, is nothing but small y bar upon x bar into capital X bar, where x bar is known value, right? So this is the value of our ratio estimator. Now we have found out that this is the ratio estimator, and now we will find out the estimation of this, the variance of this, and similar to that, everything. So first one is estimation. So estimation of y bar cap r is equals to estimation of y bar upon x bar into capital X bar. Now capital X bar is known and is constant, so it comes out, and we are left with estimation of y bar upon x bar. Now before this, let us see what is the sample size. Sample size for ratio estimator. It should be NCN, let us take equal to capital M, right? So from here, if we take out the estimation, then the probability will be 1 upon m summation I goes from 1 to m y bar I upon x bar I. So this is the estimation, which is not clearly not equal to the population mean, and hence we can say that it is the ratio estimator is the biased estimator, and hence the bias of ratio estimator can be written as estimation of y bar r minus 1 upon m summation I goes from 1 to m, this is x bar upon m, and yi bar upon xi bar. So this is the bias. Now we will distribute this YR, so, this ratio estimator such that we will such that it becomes the unbiased estimator, because we need that only. So it becomes the unbiased estimator. So it is, as we all know, that it is difficult to find the estimation of y bar upon x bar and y bar square upon x bar square. So we will take up to first approximation. So let us consider up to first approximation. So up to first approximation, let us take epsilon 1 equals to y bar upon capital Y bar upon capital Y bar, and epsilon 2 equal to x bar upon capital X bar upon capital X bar. So here small y bar can be written as 1 plus epsilon 1 into capital Y bar, and from this we can write small x bar is nothing but 1 plus epsilon 2 into capital X bar. Now we'll find out the estimation of this. Estimation of epsilon 1 is nothing but estimation of this y bar minus capital Y bar upon Y bar. This will be 1 upon capital Y bar, estimation of Y bar minus capital Y bar. Now since this has been taken from the simple random sample, so estimation of Y bar will be capital Y bar only, it becomes capital Y bar upon minus capital Y bar upon capital Y bar, which is equals to 0. And similarly, estimation of epsilon 2 is also equals to 0. Now both of them equals to 0. Now we will calculate estimation of epsilon 1 square. Why are we calculating this? Estimation of epsilon 1 and epsilon 2, we'll put the values in the formula for ratio estimator, and then after that we will take the estimation of that and variance of that. So we'll be needing both estimation of epsilon 1 and estimation of epsilon 1 square. That's why we are calculating. So it will be estimation of y bar minus capital Y bar upon y bar whole square. So it will be nothing but 1 upon y bar square, estimation of y bar minus capital Y bar whole square. So estimation of y bar minus capital Y bar whole square will be nothing but, because this has been taken again from the simple random sampling, so it will be n minus n upon capital N into n into sy square, where sy is nothing but 1 upon n minus 1 summation I goes from 1 to n yi minus y bar whole square. So this is your, now n minus 1, this is the fractional ratio is n minus 1 upon n. This is the fractional ratio. So substituting f here, we will get estimation of epsilon 1 whole square is nothing but f upon n into sy square upon y bar whole square. This is the estimation of epsilon 1 whole square. And similarly, if we calculate for estimation of epsilon 2 whole square, then it will be estimation of x bar minus capital X bar upon x bar whole square. This is nothing but 1 upon capital X bar whole square, estimation of x bar minus capital X bar whole square. So this will become 1 upon capital X bar whole square n minus n upon nn into sx square. And we again substitute the value of f, so we will get f upon n into sx square upon capital X bar whole square. This is the estimation of epsilon 2 whole square. Now putting the values in ratio estimator. The ratio estimator was given by y bar upon x bar into capital X bar. The value of y bar was 1 plus epsilon 1 into capital Y bar, and this was 1 plus epsilon 2 into capital X bar into x bar. This and this will get cancelled. So we are left with 1 plus epsilon 1 into 1 plus epsilon 2 raised to the power minus 1 into y bar. Now opening the power, and we are doing it up till first approximation. So first approximation means that the digits should be, the power of digit should be 1. So opening the bracket, we will get y bar into 1 plus epsilon 1 to 1 minus epsilon 2 plus epsilon 2 square minus epsilon 2 cube up till like this. But since there is first approximation, so all these terms are irrelevant and we will only take till this. Multiplying it, we will get y bar 1 plus epsilon 1 minus epsilon 2 minus epsilon 1 into epsilon 2. This is y cap r. Now we can take y bar here, multiplying it by 1 minus y bar. We are left with y bar into epsilon 1 minus epsilon 2 minus epsilon 1 into epsilon 2. Taking the estimation on both sides. Estimation of y bar r minus y bar is nothing but y bar. Because estimation will not apply to this, we will take the estimation inside. Estimation of epsilon 1 minus estimation of epsilon 2 minus estimation of epsilon 1 into epsilon 2. Now we had not calculated estimation of epsilon 1 into epsilon 2. Let us do here. Estimation of epsilon 1 into epsilon 2 can be written as estimation of y bar minus capital Y bar upon capital Y bar into x bar minus capital X bar upon capital X bar. Right? So this will be 1 upon x bar into y bar, estimation of y bar minus y bar into x bar minus x bar. This will be nothing but covariance between x and y, or we can write it as 1 upon x bar into y bar n minus n upon n into sxy. By putting the value of f by n, this can be written as f by n into sxy upon x bar into y bar. This is the value of estimation of epsilon 1 and epsilon 2. So putting the value in equation, this one, estimation of y bar r minus y bar is nothing but, now we know that estimation of epsilon 1 and epsilon 2 is 0. So we are taking out that and we are left with minus f by n sxy upon x bar into y bar. Now this y bar gets cancelled with this y bar and we are left with estimation of y bar r. This is the constant, so estimation on it will be this only, and this will be f by n into sxy upon x bar. And hence we can say that estimation of y bar r, or we can write it like that only. Here we can write it as bias of y bar cap r is nothing but minus f upon n into sxy upon x bar. Now we have to prove that it is an unbiased estimator also. So taking the values, estimation of y bar r minus y bar is nothing but taking the value from here. This, because we have to take the first approximation, so we will take this value and we will minus this from it because it is not first approximation value. So it will be y bar into we are not taking this estimation, y bar into epsilon 1 minus epsilon 2. Taking the estimation on both sides, we will get this. It will be estimation of y bar r minus capital Y bar is nothing but y bar into estimation of epsilon 1 minus estimation of epsilon 2. Now we know that both of them are equals to 0. So it will be estimation of y bar r minus y bar is equals to 0. So estimation of y bar r, which is the ratio estimator of mean, is equals to the population mean. Hence we can say that it is an unbiased estimator of population mean. Firstly, we have to calculate the value of bias, then we have to prove that it is an unbiased estimator, and thirdly we have to calculate the value of variance. So the third property is variance. Now what does variance say? Variance of x bar r this will be reduced to, what was the value of this? This is the value, y bar into 1 plus epsilon 1. Variance of y bar into epsilon 1 minus epsilon 2 minus epsilon 1 epsilon 2. So taking y bar out of the variance, we are left with this epsilon 1. Variance of epsilon 1 is estimation of epsilon 1 whole square minus estimation of epsilon 1. But estimation of epsilon 1 is 0. So it will be estimation of epsilon 1 whole square only, which we have calculated. Estimation of epsilon 1 whole square is nothing but f by n sy square upon y bar square. And this is f by n sx square upon x bar square, and this is 2f by n sxy upon x bar into y bar. Taking out f by n and multiplying by y bar square, we will get f by n into sy square minus sx square into y bar square upon x bar square minus 2 y bar upon x bar into sxy. If we take y bar upon x bar as r, suppose, then our formula for variance will become f by n into sy square minus r square sx square minus 2r sxy. So this is the formula for variance. Till here it is also correct, and this one step is also correct. You can write any of the following from them. So this was about the ratio estimator, estimation, bias, and variance. We'll move forward in the ratio estimator in the next class. I hope you got what we did today. If you have any doubt, you can ask in the comment section or on WhatsApp channel. Only relevant doubts will be answered. And keep on doing the work with consistency, and keep on watching the lecture videos, because we are going to cover almost all the syllabus before the examination, and we'll also be covering PYQs along with the theory part. So keep on watching the lecture videos again and again. Thank you. All the best.